software engineering CSE 350 final homework. We're presenting our project code path. I'm Robert Lovett.
You want to restart?
My
name.
Oh, we're all supposed to say our names.
Yeah.
Just leave it in.
I mean,
Let's go.
We've done it in the past. All right, we'll restart.
But we don't have Eli.
Yeah, I'll say Eli, something about Eli, or we'll just not mention him.
I'll do Eli's voice.
Okay, let's just not mention him. Maybe it doesn't matter.
Or one of you guys can be like, unfortunately, our fourth member, Eli Drake, could not be here. Something like that.
I'm not gonna. Don't even mention Eli.
Yeah, I'll go second.
3,
so
2, 1. Hello, this is our CSE 350 Software Engineering Homework 3 presentation. Our project is Code Path. My name is Robert Lovett.
I'm Jason Preby.
Luke Stallard.
And welcome to our presentation. Our project overview, once again, is CodePath. It is a web application designed to help users learn the fundamentals of a Python programming language through guided interactive lessons. Each lesson will consist of 3 panels: an instruction panel, a programming panel, and a results panel. And our site will be able to track your progress so that you can see how many lessons you've done and you can measure your growth. Currently, the project status of CodePath, it is at a point where all that is left to do is to implement the final couple of lessons and make sure they work as intended, and then, if we have time, to host it for public access. And now I'm going to hand off to Luke Stallard, who will take over the test plan.
All right. For testing, our plan focuses on all major functional requirements. This includes unit testing, individual features, UAT testing for lesson effectiveness, and specialized testing for the compiler that evaluates user code. We created test cases for each functional requirement to make sure features behave consistently. Things like account creation, lesson display, lesson completion, code evaluation, and navigation. And Robert, I'm on 5. For functional requirements, 1.1, we focused on user registration and authentication. We created 4 unit tests that validate account creation, login, logout, and password reset. The acceptance criteria are simple. Each operation must complete successfully. We use the standard laptop, Django backend, virtual environment, and a test database. Any failures were logged and sent to the programming team. For functional requirement 1.2, the lessons panel, we tested that lessons added through the admin interface correctly appear in the lesson list for users. Our acceptance criteria is that the test user should see the added lessons and be able to navigate into them. This is also handled in a controlled environment using an admin account and test lesson data. All right, functional requirement 1.3 is for the coding panel. We tested 2 things: that the user can type code with syntax highlighting and error marking. And second, the user can reset the code editor to the original starter code. If these work correctly, the test passed. If any formatting or behavior is off, the issue is logged for the dev team. All right, functional requirement 1.4, the terminal panel. For the terminal panel, we also tested 2 major behaviors. The terminal should show correct output or error messages based on the user's code. And if user submits the correct solution, the lesson should be marked complete and unlock the next lesson. All comparisons are done against reference outputs. Functional requirement 1.5 is the user dashboard. This covers profile updates. We tested 2 features. First is completed lessons should be reflected in the dashboard. And second, changes to a user profile like a picture or introduction should persist after page refresh. If both work correctly, the requirement passes. Lesson navigation. For this, we tested 3 behaviors. User must complete lessons in order. They can restart a lesson at any time, and they can freely navigate among unlocked lessons. For UAT, we partnered with an independent third-party tester with basic coding knowledge and instructed them to act like a beginner. Each lesson got up to 3 attempts. The lesson either met tester standards or didn't. If a lesson failed, we logged the reason, categorized it by severity, and sent it to the lesson team for revision. For UAT, no special hardware was required, just the text lessons files and a basic Python compiler. Each lesson had 1 test case. Did the lesson meet the standard or not? Some lessons required multiple retests, but all were capped at 3 attempts. All UAT failures were logged and ranked by severity. These were then assigned to the documentation team, the lesson content creators. After fixes were applied, the tester reevaluated the lesson until it passed or hit the retest limit. For compiler testing, we verified that our lesson evaluator can correctly determine whether the user's code is right or wrong. We compared user output directly to a predetermined solution, normalized the output, and ensured syntax and runtime errors are properly handled. We used test data that included correct code, incorrect code, syntax errors, and simulated input. We created 20 test cases, 1 for each lesson, to thoroughly validate compiler accuracy. Any instance where the compiler incorrectly 100% of the correct solutions. For resource planning, we we divided our team in our team divided responsibilities. Robert was QA lead, documentation, lesson writing. Eli, QA support, documentation, also lesson writing. Luke, front-end development and testing. Jason completed some back-end and compiler development. Now I'll pass it on to Jason.
All right, let's take a look at our software implementation. So for our actual code implementation of CodePath, we actually started by building our backend first using Django, and then went on to do the front end. And then we are eventually planning to deploy on AWS. For the backend, we use Django and PostgreSQL, and for front end, we use HTMX, Tailwind, Alpine.js, as well as Monaco Editor and Xterm.js. Next slide, please. So for our unit testing approach for CodePath, we applied both manual unit testing and automated unit testing. Manual testing was used to verify UI flow, navigation between lessons, account creation, login, logout functionality, lesson unblocking, error messages, some of the lesson workspace behavior, basically all kinds of the core website functionality. Whereas automated unit testing was used for certain components, mainly the compiler and lesson evaluator. We had a test script that would run all the lessons simultaneously with various predefined inputs to ensure that correct output is produced for valid code, syntax or logic errors are detected properly, and lesson completion logic correctly determines whether the user should be able to advance to the next lesson or not. So as for resource requirements for implementation, for hardware, all of us just kind of use standard laptop and desktops with a minimum of 8 GB of RAM. For software, a terminal connected to Django backend and a virtual environment to run the local server, a web browser, unit testing framework, GitHub for version control. And as for access levels, everyone had to have GitHub contributor access and access to Jira as well. So let's take a look at some of the implementation for our code. This is obviously not all of it, but that will be submitted for the final documentation. But first, let's take a look at some of our backend code. This is Django. We're taking a look here specifically at users model.py and lesson models.py, seeing some of the functionality for recovery codes and lesson completion, etc. And here's some of our code for our front end. Specifically, we're seeing some HTMX, Alpine, JS, and Tailwind code. This is a template on CodePath. And finally, let's take a look at some of the structure for CodePath. So CodePath is built on and based off of our Django backend. So the core structure of our repository is basically structured according to standard Django practices with things like apps.py, models.py, etc. And during the testing phase, we found and fixed 3 bugs. So originally testing case 4, 11, and 12 all failed in some way or another. For 4, you weren't automatically signed in upon resetting the password. For 11, whenever the user would select a profile picture, it wouldn't be saved. And for 12, if the user wasn't signed in, they would be able to access all the lessons originally. So all of these were found during testing and were fixed there were various implementations used to fix these problems. So let's take a look at the test scripts. So here's an overview of all of the test cases we have specifically for unit testing. So we also have user authentication, acceptance testing, which is later on, but this is just for the unit testing. So we have 14 test cases here, mainly looking at can the user create an account successfully, log in, sign in and out, recover their account by resetting the password. Are they able to reset or restart a lesson? Restart a lesson. They should be able to see results in the terminal if they run code, etc. Just testing the essential functionality for CodePath and making sure everything works. And after we fix the 3 bugs, all of our test cases pass. So here's a look at some more concrete examples. So we're looking at test case number 1 here. This is for creating an account. You can see we have the test steps and the expected results, as well as the test data and the test status. So this is just kind of a more in-depth look. And we have the same for test case 5, test case 6, test case 8. This one is basically, oh, no, no worries. Just keep going over, it's fine. And test case 10 here. And finally, for functional requirement 6, we have test case 12, more in-depth, showing everything. Let's move on. So I'm going to pass back to Robert, and we can talk about the test reports.
And so I'll also go a bit more in depth in some of the tests. So as you can see here, this is our test reports for our unit tests for the unit tests for the actual site. So for test case 1, our expected output was that the user could make an account, and after the first attempt of this test case, we were able to have the user make an account. Same for when the user was trying to log into their account or log out of their account. Both of those also passed in 1 attempt. Like we said before, the password recovery, that one was one of our more major bugs that we ran into while coding. It did take 2 attempts to do that because at first the user was unable to recover or reset their password. But we were able to fix it, and on the second attempt, it was able to pass. 5 also took 2 attempts, but we did not count it as one of our more major bugs. It was a simpler fix, as the user was just unable to see or start any of the available lessons. 6, it took 3 attempts to do. For the first attempt, the user was able to write and edit code, but it was in the wrong section. And after the second attempt, we got that moved over to the right section. For 7, that one took 2 attempts as well, because at first the user was unable to reset the pre-generated code to the starting value if needed. And here's the rest of them. For 8, was able to pass at the first one. The user was able to run code and receive the output or errors in the terminal. 9, it took 2 attempts, but the user was able to progress to the next lesson after the second attempt. 10, also, the user was able to have up-to-date stats in their profile. It only took 1 attempt to complete. 11 and 12 were, again, some of our ones that we counted as major bugs. Because for 11, we were trying to make sure any changes they were made would be saved when refreshing the page, and at first they were not. And the second time, I don't think they were saved, and it was in like the wrong section. But after the third time, we got it fixed. For 12, again, one of our major bugs, users shouldn't be able to access the lessons out of order. Like we said at first, if they weren't signed in, they could access all the lessons regardless of whether or not they had completed them. And after the second test, they weren't able to progress further, but they weren't able to progress past the lesson if they had passed it, because there was something wrong with the button, I think. But after on our third attempt running this test, we were able to pass it successfully. Restarting a lesson, that only took one attempt to do, and freely moving between unlocked lessons took 2 attempts. So some of our, going further, a little bit more in depth in the stats, we had planned for 20 test cases. We executed and passed 25 after all our debugging. Despite only creating 14 unit tests, we planned for more because test case number 9, which was testing our lessons to make sure we could pass them accurately, was broken into 20 subtests in order to test if the user could pass each lesson individually, which is why we have more test cases than we do, more test cases planned than we have test cases to run. But yeah, as I said, we ran 25 test cases, and after our debugging, we were to pass all of them. We have a 100% success rate on our test cases. During this time, we encountered about 16 defects, 3 of which were, as we said before, are major bugs that we were able to fix. But in 3 of these defects that we encountered were cosmetic and were cosmetic. For our lesson reports, here's our lessons and the feedback we got from our tester. As you can see, it ranges from things like all good to no improvements to a couple of testing for lesson 6. It took 3 tests. The first one he said you should split into sections. It's too large of a lesson for one. And then the second one he said was limit the created array size to about 3 to 4 to keep efficiency down, increase efficiency. But our feedback, this is not the exact word for word feedback our tester gave. This is more of a summary to better fit this format. Here is it through lessons 1 through 10. And then here's lessons 11 through 20, the same thing. So getting more into the stats here, we planned to do 2 tests for each lesson for a total of 40 of our UAT tests. We only executed 34 due to nearly half of our tests passing on the first try. We did have 2 lessons, 6 and 20, that are both considered failures due to how we define success. And that is because they took more than 2 tests to meet our testers' standards. This gave us a 94.118% success rate for these tests. And during this time, we encountered 22 defects, 6 of which were cosmetic. Part of the reason for this number of defects is because our tester saw some new defects when we would resend lessons. So our implementation milestones, we are mostly on schedule with CodePath, but we are slightly behind where we want to be. We still have yet to implement all of our lessons. And for our lesson user acceptance testing, we had our anonymous tester read and provide feedback on the lessons via text files, which is how we were able to get his feedback on all the lessons, despite not them having fully implemented them yet. This is something we'll definitely have done by the final documentation when that comes around to be submitted. And as for assignments and responsibilities, I and myself, Robert Lovett, and Eli Drake, we were in charge of documentation, testing design, lesson writing, and as well as kind of just reporting and all like the behind-the-scenes stuff. While Luke Stallard worked on the front end, they designed the front end, and as well as any front-end related testing, and Jason Preeve did the same with the back end and any back-end related testing. We did make sure to follow all the ethical guidelines as we respected people's ownership and avoided plagiarism by using free and publicly available tools and frameworks like Django, HTMX, etc. that anyone can use to build websites, and everything was built from the ground up by us. In terms of confidentiality, everything is handled via built-in features of Django, and all sensitive information is in databases that is encrypted. To promote diversity, CodePath is made to be easy to use and understand for everyone. And it's not targeted towards any particular audience. Any beginner of Python can pick it up and start learning right away. Thank you for coming to